Hello kids, welcome to ICSE Chemistry Hub. Please do like, comment and please do subscribe our channel. Also do share it with your friends so that even they can get the maximum benefit out of this channel. Today we will be dealing with part 4 of metallurgy. You can have a look at all the other 3 parts that I have put in the description box. The link would be provided there. So as you are aware that in the previous class, we had started with the extraction of which metal, children? We had started with extraction of aluminium metal. Okay. So today we will be continuing with the steps for extraction of aluminium. Okay. So step 1 was pulverization. What does pulverization mean? Pulverization means we had made aluminium ore, that is bauxite, into a fine powder. Then the second step that we had done is called as concentration of the ore, and it is carried out by which method, children? It is called as Bayer's process. If you have any doubt in this Bayer's process, I have explained it in detail in the previous video. Okay, so please go through it once again if you are not clear with the concept. So concentration of the ore is done by Bayer's process. The next step is we would like to convert the ore to its oxide. Okay. Now after Bayer's process, the end product that we had got was called as alumina. What is alumina? It is Al2O3. Can you see here, children? It is already in an oxide form. So we need not carry out this step because it is already in an oxide form. And what do we call this oxide as? We call it as alumina. Okay. So these 3 steps we had discussed in the previous video. Today we will be starting with the most important part of this process, that is reduction of the metal oxide to its metal. That means from Al2O3, we are trying to reduce it. Now, what is the meaning of the word reduce, children? I am trying to convert it into aluminium. Okay, so I am trying to remove the oxygen from alumina. And we know whenever we try to remove oxygen, that process is called as reduction. So removal of oxygen, that is, we are trying to do reduction of the metal oxide and we are trying to get the metal back in our hand. Now this process is called as Hall-Héroult process. Whenever from aluminium oxide or alumina we try to remove oxygen, that process is carried out by a process which is called as Hall-Héroult process, and it is a very important question that is asked in the board exam. Okay, so today we will be doing this topic in a lot of detail. Okay, and the last step, as you know, once you get the pure aluminium in your hand, you need to refine it. Now, what is the meaning of the word refining? You need to make it pure. Okay. Now, as we are dealing with which metal, children? Aluminium metal. Now, we want to reduce the metallic oxide. That means Al2O3 needs to be converted into aluminium. I want to reduce this metallic oxide. Okay. Now, I had taught you in the previous video that whenever we have a look at the reactivity series of metal, okay, this is the same reactivity series that we will be using for extraction of metals. Okay. So, we had said the top 5 to 6 metals, that is potassium, sodium, lithium we usually don't deal with, but calcium, magnesium and aluminium. These top 6 metals, okay, they have a very strong affinity with oxygen. What is the meaning of the word strong affinity with oxygen? They have a very strong love with oxygen. So when they have this strong love with oxygen, we can remove oxygen only by using the costliest method. Okay, it is because of the strong love that it becomes very difficult for us to remove this oxygen from aluminium. So which method is carried out for the top 5 metals or the top 6 metal? We always carry out the electrolysis method. Okay, and this aluminium metal comes in the top 5 metals. So whenever you have potassium, sodium, calcium, magnesium, aluminium, Please remember, whenever you have to reduce the metallic oxide. What's the meaning of the word reduce? Reduce means whenever I have to remove oxygen from them, because of their strong affinity with oxygen, because of their strong love for oxygen. What do I have? How can I remove oxygen from it? I can remove oxygen only and only by using which method, children? I can remove oxygen only by electrolysis method. Okay. So as soon as you hear aluminium, it is understood that whenever aluminium has to be extracted, you always have to reduce the metallic oxide using electrolysis method. Okay. So scientists thought, children, extracting aluminium would be very, very easy, or reducing the metallic oxide to aluminium would be extremely easy. Why? Because they thought we have alumina in our hand, which is Al2O3. So this would become our electrolyte. Simple. Okay. And then they thought we need a cathode. Now what is the charge of a cathode, children? Cathode is negatively charged, anode is positively charged, and we know opposites will attract. So aluminium oxide or alumina will decompose into Al3 plus 3O2 minus. And we know alumina, because it has aluminium, because it has a plus charge, it will be collected at the cathode, and oxygen will be collected at the anode. So I have separated my aluminium, I have separated my oxygen. So at the cathode, I will as usual get my metal, which is aluminium. But when scientists actually went on to do this electrolysis, they were facing certain difficulties. Okay, there were mainly two difficulties that they were facing while they were trying to reduce aluminium oxide or alumina, which is nothing but Al2O3. Okay, and you need to remember these problems. The problem for alone taking alumina was the high melting point of alumina. Now we know electrolysis can only be carried out in two states. Which are the two states? Either it has to be in the fused state, either I need it in the molten state, or I have to make a solution out of it. Okay. So whenever scientists were trying to melt aluminium or alumina, the melting point was 2050 degrees Celsius. Okay. So this is a lot of energy that would be required, okay, to maintain that electrolyte in a molten state. The second problem that they were facing was, at this high temperature, to melt alumina, I require 2050 degrees Celsius. But at such high temperature, my aluminium was volatilizing out. My aluminium was vaporizing out, and even before I could start with the electrolysis, my aluminium was going out in the vapor form. Okay, so this was the first difficulty that the scientists were facing. I hope that is clear to you. So what was the first difficulty that they were facing, children? The first difficulty that they were facing was the high melting point of alumina. Al2O3 used to melt at 2050 degrees Celsius. Okay, I am even ready to put so much of temperature. But what was the second problem that was coming? At such a high temperature, okay, at this high temperature, what was happening out? My metal was volatilizing out. My aluminium, even before the electrolysis was starting, it was going in vapor form. Okay, even then I am ready to do it, but then came the second problem. That fused alumina is a non-electrolyte. What is the meaning of the word non-electrolyte? Even after spending so much of energy, it is not able to conduct too much of electric current through it. Okay, so it is almost a non-electrolyte. Okay, so these were the two problems that we had faced with taking alumina alone. Okay, one was a very high melting point at such a high temperature. Aluminium itself was not remaining in the electrolyte, it was vaporizing off. Secondly, even after doing so much, my alumina is a non-electrolyte. It was not able to conduct so much of electric current. Okay. Now the solution for this problem was given by these two scientists. Okay. The name of this scientist is Hall as well as Héroult. So that is why whenever we try to reduce it, it is called as Hall-Héroult process. So whenever we are trying to convert aluminium oxide into alumina, that process is called as Hall-Héroult process. It is named after the two scientists. Okay. Now they came up with a solution. And what was the solution they gave? That do not put only alumina into your electrolyte. Instead, you should put two more things into the electrolytic mixture. Okay. So now there are three things that are added into the electrolytic mixture. Okay. First one was fused alumina. What is fused alumina? Fused alumina is Al2O3. Okay. So Hall-Héroult said that instead of just putting alumina, we will put two more things inside it. What are the two more things that they have put inside it? They had put cryolite. What is cryolite? Cryolite, please remember it. It is Na3Al6. That is sodium aluminium fluoride. Okay, so what is the next thing they have added in the electrolyte, children? They have added sodium aluminium fluoride. Okay, what is the formula of cryolite? Na3Al6. Okay, then they added one more substance into the electrolyte. What was the other substance added into the electrolyte? It was fluorspar. What is the formula for fluorspar? It is CaF2, calcium fluoride. Okay, so please do remember that Hall-Héroult suggested that in order to solve the two problems, that is a high melting point of alumina, and the second, instead of doing all this, if it is a non-electrolyte, Hall-Héroult suggested that we will put three things into our electrolyte. Which are the three things? The first thing is fused alumina, which we want to reduce. Okay. Plus they said, let us add one more. It is one of the ore of aluminium. What is the name? It is called as cryolite. What is the formula for cryolite? The formula of cryolite is Na3Al6. The name is sodium aluminium fluoride. And the next thing that they could add is CaF2, that is calcium fluoride. Now please remember, in what ratio are they added? They are added in the ratio of 1:3:1. One part of fused alumina, that is very, very little. Again, one part of calcium fluoride, which is fluorspar. What is the maximum amount we are adding, children? Which substance are we adding in the maximum amount? We are adding cryolite, that is Na3Al6. Okay. Now the question is, why do we add cryolite? This is a very, very important component of the electrolytic mixture, and this is a substance we are taken in huge amount. I hope you remember the formula of cryolite. What is the formula for cryolite? Na3Al6. There are two metals in cryolite. Which are the two metals? As you can see, you have sodium and you have aluminium. And then you have a non-metal. Which is a non-metal? Sometimes it's asked in the exam, which is a non-metal present in cryolite. Okay, it is nothing but fluorine. Okay. Now, what is the use of cryolite? As I had told you, what was the first problem with fused alumina? Fused alumina had a very, very high melting point of 2050 degrees Celsius. Okay. The moment we put in cryolite, that is Na3Al6, it brings the melting point. It brings the fusion point. The fusion point drops right from 2050. It brings it down to 950 degrees Celsius. So this much amount of less energy, less fuel, I have to provide to the electrolytic mixture. Okay. Second problem also, it is able to counteract to a certain extent. What was the second problem with alumina? It was a non-electrolyte. Okay. So when I'm adding cryolite, it is able to enhance the electrical conductivity of the mixture. It is trying to pass more electric current through the mixture. Okay. So I hope the function of the cryolite is clear to you. Once again, what is cryolite? Cryolite is nothing but Na3Al6. What is the use of cryolite? It deals with the two problems that fused alumina had. It brings down the melting point right from 2050 to 950 degrees Celsius. So it has brought down the temperature where I only have to apply less amount of fuel. And also the second problem of alumina was it was a non-electrolyte. So when I add cryolite, it will try to make it a better conductor of electricity. Clear? It was trying to conduct more amount of electricity. So we are saying it enhances the conductivity of the mixture. Now, if you remember, we are adding the third substance. What is third substance? This third substance is called as fluorspar. What is the formula for fluorspar, children? It is CaF2. Okay. Now please do remember this ion, calcium, that is Ca2 plus, and fluoride ion, that is F1 minus. These are extremely small ions. Okay. Now this is the key point in this fluorspar. Okay, what is the important thing you have to remember? Fluorspar has calcium as well as fluoride ions. Okay, now what is the speciality with calcium as well as fluoride ions? These are extremely small ions. And if you are ever held up in a traffic jam, you must have seen the smaller the vehicle is, the more quickly it is able to move. Yes or no? You can be stuck up in the traffic with a huge car with you. But if you have a small scooty or a small bike with you, you are able to find your way even through that huge traffic jam. So smaller the size of the ion, can I say more will be the conductivity. Okay? Or more easily it will be able to move. So I can say more will be the mobility. Clear? So the speciality with calcium fluoride is calcium and fluoride ions are small ions, and smaller the ion, more will be the mobility. More easily these ions will be able to move through the electrolyte. Okay? And the second most important thing is it acts as a solvent. Okay? Now solvent means it acts as a liquid into which I can dissolve my alumina. Okay? So it will help it to move faster, plus it will act as a solvent. Okay? So I hope the three things are clear to you. Okay? Which are the three things that I'll be using the electrolyte? I have my main ore, which is from bauxite I had made alumina. Then the second thing that I put in the electrolytic mixture is cryolite. What is cryolite? Na3AlF6. Okay, it brings down the melting point right from 2050 to 950 degrees Celsius, and also it increases it is a non-electrolyte, which one alumina is a non-electrolyte. So it helps it to increasing the conductivity of the electrolyte mixture. Okay. The next thing that I have added is fluorspar. What is fluorspar? Fluorspar is nothing but CaF2. So these are extremely smaller ions. More smaller the ions, they can move more faster, just like a scooty in a traffic jam. So more smaller the ions, more will be the mobility, more faster they will be able to move. And second thing is it acts as a solvent into which I can dissolve my electrolytic mixture. Okay, so these are the three things I have put into my electrolytic mixture. And who suggested this method? This method was given by Hall as well as Héroult. Okay, now this is the basic setup of the extraction or electrolytic reduction of alumina. Okay, as you can see in this diagram, we need an electrolyte. What is there in my electrolyte? My electrolyte, that is the liquid that I have taken in the container in my electrolytic cell, has alumina. What is alumina? Al2O3. What other thing I have put in my electrolytic mixture, children? Yes, I have added a substance called as Na3AlF6. What is Na3AlF6? It is called as cryolite. And I had added one more thing into the substance. What is it? I had added calcium fluoride. Okay. So I have added CaF2. Okay. And the next thing I need is an electrolytic vessel. I have taken an electrolytic vessel. Can you see the electrolytic vessel has a sloping end? Okay. It has a sloping wall kind of thing. If you are able to see it, can you see it is not a straight line, it is a slope kind of a thing. Okay. Then we require, as usual, we require a cathode. What is a cathode? Cathode is negative, as well as we require an anode which is positively charged. Okay. Now my whole electrolytic vessel, okay, this whole electrolytic vessel becomes my cathode. Okay. That is my whole container becomes the cathode. And what is the cathode made up of? Please remember, children, it is made up of carbon. Okay. Then can you see I have used many anodes here. Why I have used many anodes? I will explain it a little later. But these anodes are also made up of carbon. Okay. Carbon is nothing but it's an inert electrode. What is the meaning of the word inert electrode, children? Inert electrode means it itself will not take part in the reaction. Okay. So I hope the electrolytic cell is clear to you. I have taken an electrolytic cell which has got a slope kind of a thing. Okay, in my electrolytic mixture, I have three things. That is, I have fluorspar, I have cryolite, I have alumina. Okay, what are my anode as well as cathode made up of? My anode and cathode are made up of carbon. Carbon is nothing but an inert electrode. Okay, whenever you take graphite, whenever you take anything, it is nothing but carbon. And carbon is an inert electrode. My whole container has become the cathode here. Okay, my whole container has become the negative terminal, that is the cathode. And I have put rods here for anode, which is again made up of carbon. Okay, so this is the basic setup for electrolytic reduction. Okay, so once again, I have an electrolyte. What is the electrolyte that I have used? I have used alumina, I have used cryolite, that is Na3Lf6, and fluorspar. Okay, so these are the three things that I'll be having. Can you see here? My whole container is a carbon lining and it has been made as the cathode. Can you see here? It is attached to the negative terminal. So my whole container is lined with carbon. Okay. So this whole container becomes the cathode. Okay. So please remember it. The whole container has been lined with carbon and it becomes the cathode. Now anode, you have to remember, there are many rods which are attached to the positive terminal and there are many carbon anodes that have been placed. Now why so many anodes have been placed, we will understand it a little later. Okay, so whole container is the cathode and there are many anode rods, that is positively charged rods that are placed. Okay, now one more thing you have to remember here. Can you see here? I have placed some powdered black substance in this electrolytic mixture. This powdered black color substance is called as coke. Now what is coke, children? Coke is nothing but it is again carbon. Okay. So one of the questions that is asked is, why is the, first they will ask you to name the powdered substance X, Y, Z. What is this powdered substance that they have placed above the electrolytic mixture? The powdered substance that is placed on the electrolytic mixture is nothing but powdered coke. Now what is coke? Coke is nothing but carbon. Why it is added, I will explain to you just in a minute. Okay. So I hope this setup is very, very clear to you. I have an electrolytic cell into which I have my electrolyte. What is there in my electrolyte? I have alumina, Al2O3. I have cryolite, Na3Lf6, plus I have calcium fluoride. So these are the three things in my electrolytic mixture. Where is the cathode? The whole container for me has been lined with which metal, with which substance, children? It has been lined with carbon. So it has got a carbon lining on it and it becomes the cathode. Cathode is negatively charged and there are many carbon anodes that are placed here. Okay. Now let's come to the question that why do we sprinkle powdered coke through it? Okay. I had told I need to heat this electrolytic mixture. Okay. What is the meaning of the word heating? Why am I heating it? I need to keep my electrolyte in a molten state. Okay. So imagine if this powdered coke is not there. There are two functions of it. Right now, I'll be making you understand just the first function. Please remember the first function of this powdered coke. It prevents the heat loss by radiation. Okay. We know if we keep heating this substance here, we are heating it from down, all the heat that would have come would have dissipated out, would have gone out into the atmosphere. It would have been lost to the atmosphere. So what will this powdered coke do, children? It will prevent, okay, it will not allow the heat to move out of the electrolytic cell, or in other words, it will prevent heat loss by radiation. Okay, so this is the first and the most important function of the powdered coke. So if they ask you name this powdered substance X, Y or Z, whatever is sprinkled, it is nothing but powdered coke. Will you be able to give me the reason why that powdered coke is sprinkled on the top of the electrolytic mixture? It is because one, it has two functions. One of the function is it will not allow, you know, I am heating the mixture, I need to maintain the temperature. At what temperature? I need to maintain it at 950 degrees Celsius. Okay, so it prevents the heat from moving out of the electrolytic cell. Okay, so what is the word you will write? It prevents heat loss by radiation. Okay, so please remember the first reason, it prevents the heat loss by radiation. This point I will come to a little later. Okay, when I finish with the experiment with the electrolysis, I will come back to this point. But for the time being, you remember that what is a function of powdered coke? That layer, thin layer of powdered coke will prevent the heat loss by radiation. It will not allow heat to move out of it. Okay, so now let us start with the most important part. Many times it has come out in the exam as an important question that write the reaction at the cathode, write the reaction at the anode when you are doing electrolytic reduction of alumina. Okay, so I hope the apparatus is clear to you. I have my electrolyte. I have cathode, which is made up of carbon. I have many anodes which are made up of carbon again. So cathode and anode are made up of carbon. Cathode is negatively charged, anode is positively charged. Okay, my whole container is the cathode and my anode, there I have placed rods. Okay, on the top of it I have taken the electrolytic mixture. My electrolytic mixture has alumina, Al2O3. I have Na3AlF6, that is cryolite, and I have fluorspar. Okay, so these are the three substances and I am heating the mixture continuously so that I am able to maintain the temperature at 950 degrees Celsius. Okay, and I have put a layer of powdered coke. Okay, now what this powdered coke will do? One of the function of powdered coke is it will not allow this heat energy to escape into the atmosphere. So it will prevent heat loss by radiation. Okay, so now we will start with the equation. What are the three things that are there in my electrolyte, children? Okay, in my electrolyte I have my first substance. What is my first substance? Of course it is alumina. How will alumina decompose? How many atoms of aluminium are there? 2. Al is there. What is the valency of aluminium? The valency of aluminium is plus. Okay. What is the other ion that is present? I have how many oxygen atoms, children? I have 3 oxygen atoms. Yes or no? So 3O. You should know the valency of oxygen. What is the valency of oxygen? It is 2 minus. So I hope this equation is clear to you. But was this the only substance I have added in the electrolyte? No. I have added the next substance. Which is the next substance? The next substance is cryolite. What is cryolite? Na3AlF6. This also will decompose. Can you tell me how many atoms of sodium are there? 3. 3Na. What is the valency of sodium? 1 plus. Then I have no number here. So I will take it as 1. Al. I should know what is the valency of aluminium. It is plus 3. And then I have fluoride. How many atoms of fluoride are there? 6. So 6F, what is the valency? 1 minus. Okay. Third thing I have is calcium fluoride. Yes or no? That is fluorspar. How will fluorspar decompose? How many atoms of calcium? No number, so I take it as 1. What is the valency of calcium? 2 plus. I have 2. How many fluoride ions are there? There are 2 fluoride ions. So 2F1 minus. Yes or no, children? Okay, so these were the 3 things in my electrolytic mixture and all 3 of them have undergone the process of decomposition. Now we will start with the reaction at the cathode. What sign does the cathode have? the cathode has a negative sign. Okay, can you see my whole container here? My whole container here is the cathode. Okay, and so what is the sign on the cathode? The whole container has become negatively charged. Okay, my whole container will be negatively charged. So which ions will come towards it, children? Of course, opposites attract. Do you remember this? C to C. Cations will run and come towards the cathode. Am I clear? Now you have three cations available here. Okay, you have aluminium, you have sodium, you have calcium. All three of them come and run towards the cathode, but only one of them gets discharged. Okay, and which one of it will get discharged? We know the lower the position in the series, the more easily or the more is the ease for discharge. So we know sodium comes first, okay, potassium, sodium, and then comes calcium. So neither sodium will get discharged, neither calcium will get discharged. Who will get discharged? It will be 2Al3+. Why only aluminium? Because it is lower in the electrochemical series. Okay, so because aluminium is lower, it will be discharged first. Okay, now I will give you an easy way to remember it, children. If it is a plus here, close your eyes and put a plus here also. So 2Al3+, because there's a plus here, we will put a plus here. Now you just count the number. Now why have they come to the cathode, children? They have come to the cathode to get discharged. What is the meaning of the word discharge? They want to lose their charge. Clear? So 2Al3+, how many electrons are there? 2 here, 3 here. 2 into 3 becomes 6. So how many electrons I have to put, children? I have to put 6 electrons. Okay. Why 6? 2 here, 3 here. 2 into 3 is 6 electrons. It becomes discharge. What is the meaning of the word discharge? Discharge means it tries to become neutral. It wants to have no charge on it. Okay. So what is the metal that will come and deposit at my cathode? At my cathode, which is my whole vessel, which element will come and get deposited? Aluminium metal will come and get deposited all over through the container. Now aluminium, it's a heavy metal, so it will come and settle down. Can you see here? I have a tap here. Okay, there's a tap kind of thing where I can open it and my aluminium will be collected in one of the containers and I can easily get aluminium metal. Okay, so please remember, neither sodium will get discharged nor calcium will get discharged. What will get discharged? The ion that will be discharged is 2Al3+. 2 into 3 becomes 6. If it's a plus here, 6 electrons, it becomes 2 aluminium. So at my cathode, I get, now cathode means the entire container will get aluminium. Aluminium is heavy in weight. Because it's heavy in weight, it will always come and settle down at the bottom where I have a tap. I can just open the tap and I can collect my aluminium metal. Okay. Now let us go to the anode. What is the sign of the anode, children? I know my anode is positively charged and it is opposites attract. When I say opposites attract, you have to remember this. Anions will run and come towards the anode. Okay. So the least in the electrochemical series is 3O2-. So fluoride ions will not get discharged. Which ion will get discharged? My oxide ion will get discharged. Okay. So it is 3O2-. At the anode that is positively charged, my oxide will come and get discharged. Why? Because it is lower in the electrochemical series. Again, very, very simple. If it is a minus here, you need to put a minus here also. And we know 3 into 2 is how many electrons? 6 electrons. So 3 here, 2 here, 3 into 2 becomes 6. What it wants to get discharged. Discharge means there should be no charge. So it becomes 3O2. Now we know this 3O is very, very unstable. So it becomes 3O2. Am I clear? Or in other words, O is unstable. It combines with another oxygen and it will give me O2. Clear? So what have I got at my anode, children? At my anode, I have got oxygen gas evolving. I hope this is clear to you. Okay. So at the cathode, which metal is getting deposited? At the cathode, aluminium is getting deposited, and at my cathode, at my anode, oxygen is getting liberated, or oxygen gas is getting liberated. So we'll once again go ahead with the reactions, children. Okay. So which are the three things? I have cryolite, 3Na plus Al3 plus 6F minus. I have CaF2, which is Ca2 plus and 2F minus. I have Al2O3, that is 2Al plus 3O2 minus. This is not going to be discharged. This is not going to be discharged. At the cathode, what is going to get discharged? Will be 2A3 plus. 2 into 3, because it's a plus here, put a plus here. 2 into 3 is 6 electrons. It will give me 2 aluminium. So which metal is deposited at the cathode, children? My aluminium metal is deposited at the cathode. Okay? Which is, by the way, my whole container. Now, anions, I have fluorides. They are very high in the electrochemical series. They will not be getting discharged. Okay? So, I will have 3O2 minus coming at my anode. We know if it is a minus here, put a minus here. 3 into 2 is 6. 6 electrons and I will get 3O. 3O is very, very unstable. So, it will immediately combine with another oxygen atom to give me 3O2. Just write this much 3O. Because it's unstable, it will give me 3O2. So, please remember the products. At my cathode, I have my pure aluminium that is getting liberated. And at my anode, I have oxygen gas that is getting liberated. Okay, now your question will be, why I have written these two compounds here? Okay, so let's just have a look why I have put that. Do you remember, I have just told you about the electrolytic cell. Okay, now the question that comes here is, one, why are there so many carbon anodes that are placed here? Okay, and you will also learn in your next slide that I have put multiple, we call it as multiple anodes. Okay, these are called as multiple anodes I have put, and one other thing that I have done is, I need to replace these anodes. Okay, I need to change this anodes periodically. That means after a certain period of time, I need to change these anodes. Okay, now what is happening, children? What were my anodes made up of? My anodes, which I had used in multiple numbers, they are made up of carbon. And which gas is coming at the anode, children? Which gas is getting liberated at the anode? I have oxygen. Can you tell me? When C combines with O, what am I going to get? I will either get carbon monoxide, and if there is full oxidation happening, I will get carbon dioxide. So what will be my two products, children? This carbon will combine with oxygen. I'll once again tell, these anodes are made up of carbon. Okay. So when I make this carbon, which is the gas that is getting liberated at the anode. At my anode, I have oxygen gas liberating. Okay. Now, when carbon reacts with oxygen, if there is a full oxidation happening, I'll get CO2. If there is incomplete oxidation happening, I'll get carbon monoxide. Now, carbon dioxide is in the form of a, yes, it is in the form of a gas. So, slowly what will happen, children? My anode will start vaporizing off. Okay, it will start getting used up and it will become carbon dioxide gas. And it will slowly start reducing in mass. Okay, it will slowly start thinning out. Why does it start thinning out? My anode is made up of carbon. Which gas is coming out? Oxygen. It will give me CO2, which will go out in the vapor form. Okay, so please do remember this. This is one of the questions that is asked for your board exams also, that why multiple graphite anodes are used and why they need to be changed periodically. Okay, so please remember what is evolved at the anode, which is the gas that is coming out at the anode. oxygen gas is coming. My anode is made up of carbon. Okay, and which gas is coming at the anode? Which gas is liberated? It is oxygen gas. This oxygen gas reacts with carbon. If there is partial oxidation, I get carbon monoxide. If it is full oxidation, I get carbon dioxide. Okay, so please remember this. Because of this reaction, my carbon anode starts getting used up. It starts vaporizing out. It moves out in the form of a gas. Okay, so can I say it is used or it is consumed? And that is why I need to replace it periodically. I need to change it periodically. Okay, now one last thing. I had told you that there are two functions of powdered coke. What was the first function of powdered coke, children? It prevents, I am heating the electrolytic vessel to maintain the temperature at 950 degrees Celsius. So what is the first function? It will not allow the heat energy to escape into the atmosphere. So what were the words that I had asked you to remember? It prevents the heat loss by radiation. Now the second function of this powdered coke is it prevents the burning of the carbon anodes in air. Okay, I will just come to the diagram for one more minute here. I told you what are my anodes made up of. My anodes are made up of carbon. And after the electrolysis, which gas is coming at the anode, children? It is carbon dioxide gas, C plus O2. Oxygen is coming near it. We are getting CO2 gas. It is a very, very exothermic reaction. What do you understand by the word exothermic reaction? Okay, it will start releasing huge amount of heat. And because of this huge amount of heat energy, what is going to happen? There can be burning or there can be fire that can come at the electrode. Which electrode? At the anode. So my anode at this point where it is in contact with air, it may start burning. Okay, so this is the second function of the coke. Okay, when carbon, I am once again telling it, the first function of the coke is it prevents heat loss by radiation. It will not allow heat energy to move out, okay, by convection or by radiation. The second thing is this anode that is made up of carbon. When it reacts with oxygen which is being released at the anode, this gas is released at the anode, this carbon plus oxygen reaction is highly exothermic. So what can happen? Because it's an exothermic reaction, at the point where it is in contact with air, okay, half of it is dip in the electrolytic cell, agreed. But the one that is in contact with the air, okay, there are chances that my anode might start burning. Okay, it may catch fire because of the huge amount of heat energy that is released. So what does this powdered coke do? It spreads out the heat. Okay, what does this coke do, children? It spreads out the heat evenly. Okay, so by doing this, by spreading the heat evenly, by distributing the heat evenly, what has it done to me? It has prevented the burning of the carbon anodes in air. Okay, where we call it as the emergence point, where these anodes are in contact with air. That point, it will prevent burning. Okay, it spreads out the heat, it distributes the heat, so it prevents burning of the carbon electrodes in air. Okay, so I hope all these reactions are clear to you. Now, after you get aluminium metal, which we have done, electro refining of aluminium is done. It's done by a process called as Hoops process, which is not there in your board exams. Okay, so we will not be discussing this and we will avoid this confusion of Hoops process. Hoops process is just a method of purifying aluminium with the help of electrolysis. This won't be done in your grade 10 portions. So this is all about this chapter, metallurgy. I hope you have understood the electrolytic reduction of alumina to aluminium, because this is a very, very important diagram based question that comes in the board exam. In the next video, we will be discussing the important board questions that have come in the previous years, and we will be sorting out for the answers of that. Okay, so please do stay tuned. Please keep learning, please keep revising, and please don't forget to subscribe, share, and please do comment your valuable comments to us. Thanks a lot.